This video is about interior angle sum, and this is 7.1 in your packet. And up till this point, we've been studying almost exclusively of triangles. And from now on, we're going to include more on polygons, so there will be more sides. However, you will realize it doesn't get any harder because polygons, a lot of the theories and calculations are very, very closely related to or dependent upon the calculations and theories of triangles. So let's take a look at interior angles. We know by now, all of you know really well that triangle has three sides, and if I add all three angles, interior angles together, and it doesn't matter what shape, what kind of triangle it is, it will add up to 100, it will add up to 180. That should be going here. 180. And obviously that's one triangle, right? So now quadrilateral, notice how I drew the diagonal line together, how I drew the diagonal line here. And by doing that, I cut the quadrilateral into two triangles. And I have quadrilateral, I have four sides. And we know for this one in particular, if it's a rectangle, you know it adds up to 490 degrees, adds up to 360 degrees, right? Now, if I have a pentagon, I can cut that pentagon into three different triangles right here, 1, 2, 3. And pentagon obviously has 5 sides, and now I have 3 triangles. And if each triangle, the interior angle adds up to 360, adds up to 180, and then that becomes 180 times 3, and I would have 540. Hexagon, I have 1, 2, 3, 4 triangles. So I have 4 triangles, but I have 6 sides. So it becomes 4 times 180, or 180 times 4. It's 720 degrees. Right? So you can, by this theory, you can just know, by this pattern, you will know, it doesn't matter how many sides I give you. Heptagon has 7 sides. And therefore, look at this pattern here, 3 to 1, 4 to 2, 5 to 3, 6 to 4. So 7 minus 2 would give me 5 triangles inside. 5 times 180, I should have 900 degrees. Octagon has 8 sides, therefore 6 triangles. 6 times 180 is 1080. Nonagon, do I have enough space at the bottom? That's 9 sides and 7 triangles. 7 times 180 is 1260. And we already done the top 3. The last one, decagon, 10 sides. Therefore 8 triangles inside. 8 180. Yes, it's 1440. Check my mental math. I sometimes make too many mistakes when I do math quickly, when I do arithmetic quickly. So if you look back on your chart, you will see a pattern between the number of sides. I'm just going to, for the sake of my screen here, I'm going to fill this in. Is that right? That's 9. So that should be 5, 6, 7, 8, right? So you see that there's a relationship between the number of sides to the number of triangles inside the polygon. And if I find out the number of triangles inside the polygon, then I can just multiply that number with 180 and get my interior angle sum. So in conclusion, over here, if n represents the number of sides of a polygon, then the sum of interior angles can be found by using which formula? So we said the sum can be the number of sides, it's n, but in order to find the number of triangles, I need to use the number of sides minus 2. That's how many triangles inside a polygon. And once I get the number of triangles inside, I multiply that by 180 because each of these triangles inside the polygon adds up to 180. The interior angle sum of those triangles adds up to 180. Okay, so if I ask you to calculate the interior angle of one regular polygon, what is a regular polygon? If you recall, a regular polygon are those with all sides being equal. So a square is a regular polygon. An equilateral triangle is a regular polygon. So all sides being equal is the definition of regular polygon. But we know how to calculate the sum. Now we can actually calculate just one angle of that. So let's look at this. It says a regular polygon is one which all sides are equal. Therefore, all angles are equal. And to find the measure of an interior angle in a regular polygon, we use the sum of interior angles, which is what we learned just now, divided by the number of sides. Another way of writing this, if I want to expand this, I can say number of sides of the polygon minus 2 give me the number of triangles inside. I multiply by 180 gives me the interior angle sum, and then I use that to divide by number of sides. That will give me one angle measure in a regular polygon. So let's look at some practices here. It's fairly straightforward. I actually recommend some of you, if it's helpful, you just use the bottom half of the last page, put these formulas in front of you and simply plug them in. Find the sum of interior angles of a 15-gon. So number of sides is 15. And if the formula is n minus 2 times 180, so that should be 13 times, which is 15 minus 2 times 180, then that should give me 2340. What's the measure of each interior angle of a regular polygon, a regular pentagon? So I first have to find the total sum of the interior angle, which is, the formula is n minus 2 times 180. And then that becomes 5 minus 2, which is 3 times 180, and that's 550. And to find one angle, it's simply 540 divided by the number of sides, which is 5. And that should be 108, right? So that's how you use interior angles sum, and how to find one interior angle measure for regular polygons. So next, let's look at exterior angle sum. Without getting into the details, this is what I want you to know, guys. It doesn't matter how many polygons you have, how many sides you have in a polygon. All the exterior angles of any polygon adds up to 360 degrees. So if you want to prove that, you can look at the examples below. And obviously we know that all exterior angles are always supplementary to their adjacent interior angles. So I would have 119 here, I would have 101 there, and I would have 140 here, right? Also notice that the exterior angle of any polygon is simply by extending one of the sides over, and then you'll find the exterior angle. So you add all the exterior angles together, you should have 360. Same thing with quadrilaterals, 71, so I should have 109. 124 supplementary is 56 here, 104 on this exterior angle, and 91, right? 91 in this one. You add them together. I didn't even bother to use my calculator. I just know that it's 360, but verify that with your calculators. Let's see here. Pentagon this should be the same. That's 82. That is 59. 93, 50, and 76. And you add that together, that should give you 360 as well. So you can do the hexagon exercise on your own. It doesn't matter what it is. You will find out that as long as I ask you to calculate the exterior angle sum, you will always have everything add up to 360. So the sum of the exterior angles of any polygon is 360 degrees. So a couple of quick practices. What is the measure of each exterior angle of a regular hexagon? So that's 6 sides, and I know that if all the exterior angle of a hexagon adds up to 360, I have 6 sides. It's a regular hexagon, right? So each exterior angle measures 60 degrees. And number 6, what's the measure of each exterior angle of a regular 24gon? Same thing, 360 divided by 24. If the exterior angle of a regular polygon measures 12 degrees, how many sides does the polygon have? So if it's one angle and it's a regular polygon, so whatever number of sides multiplied by one angle should give me the total of 360. And x, or n, my n, equals 30. So I'll leave the last one to you guys because I'm making this video early in the morning and my children are up and they're making noises in the background. So I will see you guys in class. Okay, have a good day. Bye.